counting sheep, when you're trying to sleep, being fair, when there's something to share, when you know how much money you owe. That's mathematics.
Welcome to our lesson on decimals and place value. In this lesson, we're going to review the names of the place values and then look at how to perform different operations with decimals. Let's start our look at decimals by reviewing place value with this number, 42357.9618. If we start in the middle, 7 is in the ones place, and 7 is 7 times 1. Moving to the left takes us to the larger place values. 5 is in the tens place. It's worth 50, because 50 is 5 tens. 3 is in the hundreds place, and it's worth 300, which is 3 100s. 2 is in the thousands place, worth 2,000. It's 2 thousands. 4 is in the 10,000s place, and it's worth 40,000, because it has 4 10,000s. Notice that the place value gives the value of each unit in that place, while the digit tells us how many of them we have. Now we can move to the smaller place values on the right side of the decimal point. 9 is in the tenths place. This means we have 0.9, which is 9 tenths. 6 is in the hundredths place. It's worth 0.06, which is 6 1/100ths. 1 is in the thousandths place. It's worth 0.001 because we have 1 1/1000th. Finally, 8 is in the 10,000ths place. It's worth 0.0008, and it means that we have 8 1/10,000ths. Because the 10,000ths place is the smallest place there is a digit in, we would read this number like we would if it were a mixed number. 42,357 and 9,618 10,000ths. There are other place values beyond the 10,000s to the left and beyond the 10,000ths to the right, but the way they progress is somewhat simple. After 10,000s, you have 100,000s or 100,000ths. Then you have millions or millionths, and so on. Addition and subtraction work the same when decimals are involved. So let's look at the problem 3 463 thousandths minus 2 89 100ths. In order to subtract, we need to line up the decimal points, if we write it vertically like you see here. But how do we subtract when there's no digit below the 3? You can simply put a 0 in the empty space below the 3. This is how you'll always handle addition or subtraction problems when the numbers don't have the same number of places. You just put zeros in the empty spots. Now we can just subtract as usual. We bring the decimal straight down, so we have our final answer, 573 thousandths. To see how to multiply, let's try 3 463 thousandths times 2 89 hundredths. Let's multiply it first, however, ignoring the decimals. We start by multiplying 3463 by 9, which equals 661167. Next, we multiply 3463 by 8. Since the 8 is in the second column, we will put a 0 in the first column as a placeholder, then do the multiplication to get 5877040. Finally, we multiply 3463 by 2, putting zeros as placeholders in the first two columns, then do the multiplication to get 146926 with the 2 zeros as placeholders at the end. Now we just need to add up the columns to get 212,30807. But we forgot about the decimals. Don't worry, because we wouldn't have done anything different up to this point anyway. What we need to do now is to count up how many decimal places were in the two numbers we multiplied combined. We see there are 3 decimal places in the first number and 2 decimal places in the second number. 3 plus 2 is 5, so we need to have 5 decimal places in our final answer. 1, 2, 3, 4, 5. This gives us our final answer, 212.30807. If we look at the place values, we have tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So we could also read this number as 212 and 30,807 100 thousandths. Adding up all the decimal places is an easy rule to memorize, but let's take just a moment to see why it works. We could rewrite our multiplication problem like this. 3,463 times 1 1,000th times 289 times 1 100th. The 1 1,000th takes the place of the 3 decimal places, and the 1 100th would have given us the 2 decimal places. Now when we multiply, we still get the 212,30807, but it's multiplied by 1 100,000th. That's where the 5 decimal places come from, because 1 100,000th is like dividing by 10 to the 5th power, which moves our decimal place over 5 places. Finally, let's look at how we would divide with decimals by doing the problem 15.4375 divided by 4.75. First, you need to convert the problem so you're dividing by an integer. You probably remember the rule of just moving the decimal point over 2 places like this to get 1,543.75 divided by 475. But what's really going on here? What we're really doing is multiplying by 10 over 10 to move the decimal place to the right until we are dividing by an integer. You can see this easier if we write the problem as a fraction. To get the decimal points to move 2 places, we're really multiplying by 10 over 10 twice, which is 100 over 100. 10 times 10 is 100. Now that we understand that, let's go back to our original problem and do the division. First, we'll bring the decimal point up into our answer. Next, we need to see how many times 475 goes into 1,543, because 475 won't go into 1, 15, or 154. 475 goes into 1,543 3 times. Now we multiply the 3 by 475 to get 1,425, which we'll subtract from 1,543. When we subtract, we get 118, and we bring down the next digit 7 to get 1,187. 475 goes into 1,187 twice, so we put a 2 in our answer. Then multiply 2 by 475 to get 950. We subtract 1,187 minus 950 and get 237, and bring down the 5 to get 2,375. Finally, 475 goes into 2,375 5 times evenly. So we have our final answer, 3.25.